Hello, my name is Roy Simpson. I'm a professor of mathematics at Casitas River College in Sacramento, California, and this is another video on proofs in differential calculus. And this is a proof that the derivative of a constant is equal to 0. The best way to kind of view this idea is to think of our function as a constant, and to recall that the derivative, that a constant function is just a horizontal line, like so. So this might be the function y equals c. Now remember, the derivative itself always returns the slope of the curve at any given point, and the slope of this line at any given point is always 0. So in this case, that's what this theorem is essentially saying. The derivative of a constant function is always 0, or the slope at any given point along a constant function is 0. That's a conceptual way of viewing this. Our knowledge base for this proof is going to have to require limits. We have to know about limits, specifically the limit definition of a derivative. So with these two pieces of knowledge, we can go ahead and prove this theorem. And before I start, I just want to also tell you, if you're one of my students, that this is an easy proof that could easily be asked for you to show in any type of exam. Although this is actually a little too easy for an exam, but there are some other proofs involving derivatives of polynomials and whatnot that you could easily be asked during an examination. So here we go with the proof. Let's go ahead and let our function f of x equal c, where c is a constant. Now, by the definition of a derivative, we happen to know that the derivative function f prime of x is equal to the limit, and I'm going to use the limit as h approaches 0. Some people like the other version of the definition of a limit, but I personally like this one the best, of f of x plus h minus f of x all over h. And this is as h goes to 0. So let's go ahead and try this out. Let's see. If you go to your function here and you plug in x plus h, well, there's no x's to plug into. There's no variables in this constant function. So the f of x plus h is actually c. And f of x itself is actually c. Well, c minus c is 0. So that's just the limit as h approaches 0 of 0 over h. Well, 0 over anything is just 0. And that is actually our proof. Not too much to it, correct?